So in this example, instead of storing the values of feet and inches directly, we store pointers to them. This means feet and inches are dynamic attributes. They do not hold the actual data, but the memory addresses that pointed somewhere else. Now look at what happens in main. We define two separate variables f and I and pass their addresses to the constructor of d1. Then we create another object d2 as a copy of d1. When that happens, the default copy constructor simply performs a shallow copy, meaning the memory addresses stored inside d1's pointers are copied directly to d2. So now both d1 and d2 contains pointers to the same external variables, that is the same memory locations for f and I. That might seem harmless at first, but it can lead to a serious problem. For example, especially if one of the object modifies or deletes the data, leaving the other with a dangling pointer. This is the classical example of why shallow copying fails when classes use pointers or dynamic memory. So to fix this, we need to implement a user-defined copy constructor that performs a deep copy, allocating new memory and copying the actual values so each object manages its own separate data safely.